Welcome back to Science in Sleeping. It's always a joy to know you are here, joining me on this quiet journey into the cosmos. Maybe you've had a long day filled with responsibilities, with thoughts that refuse to slow down, or maybe you simply crave the comfort of gentle words, the way they can carry you away, like a soft tide rolling against the shore. Tonight we're drifting into a fascinating corner of the universe, a place where stars end their life in a spectacular way, and yet, from that ending, something mysterious and beautiful is born. We are talking about neutron stars. What happens after a star explodes? What remains when the brilliance fades? And why these dense, quiet remnants might hold some of the deepest secrets of physics. But as always, this journey has a dual purpose. I hope it nourishes your curiosity, giving your mind something gentle and intriguing to hold. And I also hope it lulls you toward rest. You do not need to remember a single detail. There will be no quiz, no expectation. You are free to simply listen, to let the words drift past like clouds on a night sky. If you find your eyelids growing heavier, that's perfectly fine. If you drift away into dreams while I'm still speaking, that too is exactly as it should be. Science in Sleeping is a space for both learning and letting go. And I'd love to know where you're joining from, what city or country, what time of night it is. I imagine you there, perhaps lying in bed, perhaps with a soft blanket pulled close, maybe the glow of your screen dimmed low, maybe headphones carrying my voice directly to you. In this moment, even though we are far apart, it feels like a shared space, a community of curious dreamers spread across the world. And together, we are choosing to rest. So give yourself permission now to release whatever weight you've been carrying today, the emails that went unanswered, the tasks still waiting for tomorrow, the conversations that linger in your thoughts. They can all rest too. You have nothing to prove here, nothing to perform. This is your time. Breathe in deeply and let the breath leave slowly. Feel your body softening against the bed, your shoulders sinking, your hands growing warm. Even as your mind listens, your body is allowed to rest. Now settle in, get comfortable, and let us begin our exploration, the story of neutron stars. Born in the silence after a star explodes, a story that will guide us through the night. Have you ever wondered what happens when the life of a star comes to an end? Not just the quiet fading of our own sun, but the dramatic, fiery ending of a star far larger and more powerful. It's almost like asking what happens when a giant exhales for the last time, leaving only a whisper behind. And in that whisper, a secret so dense, so strange, it defies almost everything we know about matter. Picture yourself standing in a wide open field on a cool night. The sky above you is endless, velvet dark, with the soft shimmer of stars scattered like tiny lanterns. Each one seems peaceful from where you are, glowing faintly and steadily, but in truth, many of these points of light are living through lifetimes we can hardly imagine. Some are just being born in clouds of dust, others are in their middle years, and a few are already approaching their final breaths. And when one of the massive stars reaches that final breath, the stage is set for a cosmic drama unlike anything on Earth. Stars are not eternal, even though they shine for millions or billions of years. At their core, they burn with the fuel of nuclear fusion. pressing hydrogen atoms together so tightly that they fuse into helium, releasing enormous amounts of energy. It is this process that keeps the star alive, a balance between the outward push of energy and the inward pull of gravity. As long as the fuel continues, the star remains stable. A brilliant engine in the dark, but fuel is not infinite. And in the case of very massive stars, the ending is far more violent than a quiet fading. As the star burns through its hydrogen, it begins to fuse heavier elements, helium into carbon, carbon into oxygen, and so on, layer by layer, like the rings of an onion. New shells of fusion form inside the star, until finally iron is produced. And iron is where the story changes dramatically, because iron cannot release energy through fusion. It is the end of the line, and once a massive star builds up an iron core, gravity begins to win. The core collapses inward in an instant, the outer layers rushing down, then rebounding in a titanic explosion we call a supernova. For a moment, that star can shine brighter than an entire galaxy, its light traveling across millions of years to reach us. And in the wreckage left behind, something strange and remarkable is born. A neutron star. Think of this. A star many times the mass of our sun collapses into an object only about 20 kilometers across. That's smaller than the distance you might drive between two neighboring towns. Yet, inside that tiny sphere is more mass than the sun itself. The matter is crushed so tightly that protons and electrons merge into neutrons, creating an object so dense that a single teaspoon of neutron star material would weigh billions of tons. It is like taking a mountain and pressing it into the size of a pebble, and the surface of such a star is unimaginably strange. Its gravity is so strong that if you dropped something from just 1 meter above, it would smash into the surface at thousands of kilometers per second. And yet, as bizarre as this sounds, neutron stars are real, and astronomers study them through the faint beams of light and radiation they emit. Some spin rapidly, flashing like cosmic lighthouses, pulsing with incredible precision. These are called pulsars, and their steady rhythm has even been compared to the ticking of a universal clock. Did you know that the first pulsar was discovered by accident in 1967 by a young researcher named Jocelyn Bell? At first, the signals were so regular that the team even jokingly nicknamed it LG for little green men, as if it might be aliens calling. But it was not aliens, it was the heartbeat of a neutron star, a soundless rhythm carried through the cosmos, reaching us across unimaginable distances. And so, in this story, we find an almost paradoxical comfort. The ending of a massive star is not an ending at all, but a transformation from blazing light to silent density, from outward brilliance to inward mystery. There is a kind of poetry in knowing that even in collapse, there is creation. Even in destruction, there is something left behind. And perhaps this mirrors our own lives in some small way. That change, even when it feels overwhelming, can carry with it new forms, new rhythms, new quiet truths. As we listen to the story of neutron stars, we are reminded of the resilience of the universe. And in that resilience, perhaps we find permission to rest, to trust that transformation is a natural part of being. So let's carry this gentle wonder forward. We have just touched the beginning of the neutron star's story. From here, we'll wander deeper, exploring the way they spin, the way they shine, and the strange mysteries they still hold, all at a pace as calm and unhurried as the night itself. Because there is no rush, only curiosity, and with that curiosity, we drift softly into the next chapter of our journey. Have you ever wondered if the universe has its own rhythm? A pulse, a steady heartbeat, repeating across unimaginable distances. What if the stars themselves were drummers in the cosmic symphony, keeping time not in seconds or minutes, but in flashes of light sweeping through the darkness? This is not a fantasy, but the reality of pulsars. And their story begins with the silence after a star explodes. Imagine, once again, that lonely neutron star, a tiny fragment of a once massive star, spinning alone in the dark. But not silently, not still. Instead, it spins with astonishing speed. Some rotate several times each second, others hundreds of times per second. Their magnetic fields twist and stretch, like invisible ropes, pulling energy into beams of radiation. And these beams sweep across the universe like the beams of a lighthouse. Only instead of guiding sailors across seas, they mark their presence to distant galaxies. They flash again and again, steady, unwavering, like the ticking of the most reliable clock you could ever imagine. Now close your eyes and picture yourself standing on a rocky cliff above a calm ocean at night. The waves hush against the shore. The moon casts a silver glow, and in the distance, a lighthouse beam sweeps across the horizon. It vanishes, then returns, steady, reliable, predictable. This is the same feeling astronomers had when they first noticed pulsars. At first, they thought the signals were too regular to be natural. They were so precise, so clock-like, it seemed more like the tapping of an intelligent hand. And for a brief, breathless moment, the scientists whispered to themselves, could it be aliens? In 1967, a young graduate student named Jocelyn Bell was poring over miles of radio data, lines on paper that most would dismiss as noise, but her eyes caught something, a pattern, a series of pulses, sharp and unwavering, repeating every 1.3 seconds. The world had never seen anything like it. She and her colleagues, puzzled and careful, labeled the mysterious source LGM1, a playful code for little green men, because what else could tick with such precision across light years? But soon, more signals were discovered, different pulsars, all flashing their silent rhythm, and the mystery deepened. It wasn't alien, it was stranger, it was nature itself, showing us a kind of order we had never imagined. A pulsar is born when a neutron star's magnetic field is tilted relative to its rotation. As the star spins, the beams of radiation sweep across the cosmos. If Earth happens to lie in the path of those beams, we see a pulse each time it passes, like the blink of a cosmic eye, like the rhythm of a beating heart. And unlike so many chaotic events in space, pulsars are astonishingly steady, so steady that scientists have used them as natural clocks. Their pulses can be more precise than the best atomic clocks made by humans. Imagine that, a collapsed star, spinning faster than a blender, broadcasting a message of perfect time across billions of kilometers, and we, tiny creatures on a pale blue dot, are able to catch it. Did you know that the fastest pulse, called millisecond pulsars, spin over 700 times per second? That means their surface is moving at nearly a quarter of the speed of light, a speed so incredible it bends our understanding of physics. And yet, there they are, keeping time with cosmic patience, like dancers twirling endlessly, never stumbling, never tiring, even after millions of years. But what makes pulsars truly fascinating is not just their rhythm, it's their mystery. Because every pulse is like a whisper from the edge of understanding. Why do they maintain such stability? How can matter under such crushing gravity spin without tearing itself apart? And what do they mean for our understanding of the fabric of space-time? These questions linger like stars behind clouds. Always close, always out of reach, there is something almost haunting in the thought that across the endless silence of space, there are these signals, sweeping beams, calling out again and again, not for us, not for anyone, simply because that is what they are. It feels almost like the universe breathing. And perhaps in hearing these pulses, we too can breathe more deeply, letting their rhythm steady our own restless thoughts, like a heartbeat guiding us into calm. And think about this, pulsars, these remnants of cosmic death, have become tools for navigation. Astronomers dream of using them as a galactic GPS. Because their signals are so reliable, a spacecraft could one day find its position anywhere in the galaxy. Not by relying on Earth, but by listening to the lighthouses of the cosmos. Imagine future explorers drifting far from our planet, guided not by maps or compasses, but by the pulse of dead stars, like sailors guided by the steady light of a beacon across a stormy sea. There is something profoundly comforting in that idea, that even in death, a star can guide the way. And so, as we lie here tonight, listening to the story of pulsars, let us reflect in their silent, endless rhythm. They remind us that order can emerge from chaos, that endings can carry new purposes, that even collapse can lead to guidance. Perhaps this is a message for us too, that in the moments we feel most broken, there may still be something steady within us, a light, a rhythm, a pulse that can guide us forward. And even if no one else sees it, it is still there, it is still shining, just as the pulsars shine, unseen by most, yet constant, unwavering. The universe keeps its beat, and so can we. So let this thought carry you softly onward. The cosmic lighthouse is still sweeping, its beams steady in the night, and as we continue our journey, we will look closer still at these neutron stars, at the strange physics that governs them, at the mysteries of magnetars and the whispers of gravitational waves they send into space. But for now, rest in the comfort of their rhythm, the gentle, endless ticking of the stars. As steady as your own breath, have you ever wondered what the most extreme thing in the entire universe might be? We often think of black holes, swallowing everything around them, bending even light. But there is another contender, less famous, but perhaps even more mysterious. A creature of the cosmos so rare, so strange, that scientists only know of a handful scattered across the galaxy. These are magnetars, the magnetic monsters born from the ashes of dying stars. Picture yourself standing in a quiet forest at night. The air is still. The trees rise like shadows against the faint glow of the sky. And then imagine a sudden, invisible force pulling at every compass, twisting every needle, bending every hidden field around you. You cannot see it, but you feel it. It is power beyond measure. This is what it might be like to stand near a magnet. If such a thing were possible, which, of course, it isn't, because no human could survive its presence. A magnetar is a type of neutron star. But while most neutron stars already carry intense magnetic fields, a magnetar pushes this intensity into the unimaginable. Its magnetic field can be over 1,000 times stronger than that of a typical neutron star. To put that in perspective, the magnetic field of Earth protects us from solar radiation. It guides our compasses. It shapes the auroras dancing in polar skies. But a magnetar's magnetic field is so powerful, it could erase every credit card on Earth from thousands of kilometers away. It could strip the electrons from atoms, tearing matter itself apart. Even the strongest laboratory magnets on Earth are toys in comparison, like trying to compare a candle's glow to the blazing light of a star. And yet these monsters are small, only about 20 kilometers across. But inside them lies the crushing weight of matter, collapsed into neutrons. And around them spins an invisible storm of magnetic energy, sometimes quiet, sometimes violent, because a magnetar does not always sleep. It can awaken with terrifying force. Did you know that in 2004, astronomers detected a sudden flash of light, a burst so powerful it passed right through our solar system? For a brief instant, it was the brightest event ever recorded beyond the sun. The source was a magnetar called SGR 1806-220, located more than 50,000 light-years away. And yet, even from that distance, it overwhelmed detectors on Earth. Had it been closer, only a few light-years away, it might have scorched our planet. That is the terrifying beauty of magnetars. Their outbursts can shake the galaxy. But how does such a small object produce such power? It begins with stress. The crust of a magnetar, thin but rigid, strains under the immense pressure of its own field. Imagine the surface of a star cracking like the ice on a frozen lake. Except here, the cracks release not water, but violent radiation. Gamma rays and X-rays burst out. Flares so intense they can momentarily alter Earth's atmosphere. Astronomers call these events starquakes, and in a sense, that's exactly what they are. The quaking of a star's surface, echoing through the cosmos. There is suspense in the thought that something so small, so far away, can still send its energy racing across space to reach us. Invisible, unstoppable, a whisper from a monster. And we only ever catch fragments of its voice, bursts that last fractions of a second, enough to remind us that the universe holds dangers and mysteries beyond our imagining. But beyond the danger, there is awe, because magnetars are also clues. Windows into physics we cannot reproduce on Earth. Their magnetic fields bend not only matter, but light itself. They may twist the very vacuum of space, causing light to split and polarize in ways that confirm theories of quantum mechanics. It is as if each magnetar carries the secret script of the universe, written in a language we are only just beginning to learn. And so we reflect. Perhaps there is a strange comfort here, that even in their violence, magnetars remind us of beauty. They are storms, yes, but storms have rhythms. Storms have cycles. They flare and then they sleep, just as we too have moments of turbulence and moments of rest. The universe mirrors us in its extremes, and from that mirror we might take solace. That chaos is never the whole story. that even after a quake, calm can return, even after a flare. Silence comes again. Imagine lying in bed, listening to the steady rhythm of your breath. Inhale, exhale. The rise and fall of your chest is its own cosmic pattern. It is gentle, it is steady, and in that rhythm, you are not so different from the stars themselves. Even magnetars, wild as they are, follow their own hidden patterns. It is a reminder that the universe is not random chaos, but a tapestry woven from rhythm and repetition, a dance of light. As we leave the magnetars behind for now, let us carry their story with us, not as a tale of fear, but of wonder, that in the darkest corners of the galaxy, even the most terrifying forces are still bound by beauty, bound by laws that reveal more than they conceal. And we, tiny travelers of the night, have the privilege to listen, to learn, to drift into sleep with the stars whispering their secrets. As we move forward, we will explore still stranger mysteries. How these neutron stars, pulsars, and magnetars ripple the very fabric of space-time itself. How their collisions send waves across the universe, whispers we call gravitational waves. But for now, breathe deeply, rest in the silence, and let the magnetar's hidden storm fade into the distance as you drift, safe and steady, into the night. Have you ever wondered what happens when two of the densest objects in the universe finally meet? We know that stars are born. They live, and eventually they die. But sometimes, what remains after their death does not drift quietly apart. Instead, two remnants, neutron stars, circle each other for millions of years, bound by gravity, spiraling ever closer, until at last they collide, and in that collision, the universe itself seems to tremble. Picture yourself on a quiet mountainside, the night air cool, the sky infinite. You feel the ground beneath you, solid and steady. Yet imagine that far across the cosmos, an event so powerful has just taken place that it sent a shiver through space-time itself. The very fabric of reality rippling outward, passing silently through you as if you were standing in a calm lake, and a distant pebble had disturbed the water. This is what we call a gravitational wave, and in many cases, the source is the merging of neutron stars. Neutron stars are already extraordinary. Objects so dense that a teaspoon of their material would outweigh mountains. But when two of them become partners in orbit, they dance a slow, inevitable dance, each circle bringing them closer, each rotation stealing away a little of their energy until their orbits shrink, until the dance quickens, until the moment of impact arrives, and then, in a flash that rivals the birth of galaxies, they merge. The energy released in these moments is staggering, more powerful than anything we can create or imagine on Earth. Gamma rays burst out, visible across the universe. Heavy elements like gold and platinum are forged in the crucible of that collision. It is no exaggeration to say that the jewelry we wear, the gold in rings and necklaces, the platinum in technology, may have been born in the violent embrace of two neutron stars. Think about that, the atoms resting against your skin tonight, once scattered as light in the wake of a cosmic catastrophe. But perhaps the most mysterious gift of these collisions are gravitational waves, ripples in space-time, first predicted by Albert Einstein over a century ago. For decades, they were only theory, whispers on paper, until recently, when humanity finally learned how to listen. In 2015, the LIGO Observatory in the United States detected its first gravitational wave. It was caused by two black holes colliding. But in 2017, for the first time in history, astronomers caught the signal of two neutron stars spiraling into each other. It was called GW170817, and it changed everything. Imagine the suspense. Scientists across the world watching their instruments, the data revealing a ripple that began 130 million years ago when dinosaurs still roamed the Earth. That ripple traveled all this way, crossing galaxies, and finally brushed against our detectors. It was faint, almost nothing. Yet it told us a story of unimaginable violence. Two stars colliding in silence, sending their echo across the universe. And humanity, for the first time, was listening. And here is the astonishing part. For centuries, we have studied the universe with light, with telescopes capturing stars, galaxies, and nebulae. But gravitational waves gave us a new sense. Like suddenly discovering hearing after living only with sight, the universe became richer, fuller, more alive. We could not only see, but feel. Every ripple carries a story. Of collision, of creation, of transformation. Stories written not in light, but in the trembling of space-time. Did you know that the final moments before neutron stars collide, they spin around each other hundreds of times per second? The sound of their orbit, if we could hear it, would rise like the chirp of a bird, growing higher and faster until it ends in silence. And that silence is filled with a new object, sometimes a heavier neutron star, sometimes a black hole. The final fate decided in the violence of the impact. There is something profoundly moving in this, that the universe, in its most violent moments, is also creating beauty, forging gold, scattering light, sending ripples of gravity through space. It is destruction, yes, but also creation. And perhaps this too reflects in our lives, that endings, no matter how sudden, can carry within them the seeds of beginnings, that even in collision, something new is born. So let us reflect together, lying here, breathing steadily. The universe itself breathes with us, its pulses, its collisions, its ripples moving endlessly outward. The fabric of reality is not fixed. It is alive. It trembles when stars collide. It shifts when masses move. We are not separate from it. We are woven into it. Your breath, your heartbeat, are as much a rhythm of the cosmos as the merging of stars. And so, we let this image linger. Two neutron stars, locked in their timeless dance, spiraling closer, faster, brighter, until they meet. Until the universe itself shudders, until light and gravity race outward together, some of it reaching us here tonight. As we lie in quiet reflection, safe, calm, at rest, from here, our journey will drift into another mystery. What happens when neutron stars meet not each other, but the abyss of a black hole? A darker, deeper story. One we will explore gently, one step at a time. But for now, feel the calm of the night, the soft steadiness of your own breath, and let the ripples of this story fade into dreams. Have you ever wondered what happens when two of the strangest objects in the universe find each other? We know neutron stars are dense remnants of exploded stars. We know black holes are the ultimate abyss, swallowing everything that comes too close. But what if the two were drawn together? What if the pulsing remnant of a star and the silent gravity of a black hole became partners in a cosmic dance? The answer is both terrifying and mesmerizing. Picture yourself standing at the edge of a vast canyon. You cannot see the bottom, only darkness that seems to pull at your eyes. Now imagine a single stone balanced on the edge, trembling. It does not fall yet, but gravity is always there, whispering, waiting. This is the fate of a neutron star as it drifts too close to a black hole. No matter how dense, no matter how strange, it cannot resist the pull forever. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. Their boundaries are called event horizons. And once something crosses that horizon, it is gone forever, lost not just in space, but in time itself. When a neutron star approaches such a boundary, we witness one of the most suspenseful dances in the cosmos. The neutron star may orbit for a while, spiraling in closer, its own immense gravity straining against the deeper pull of the black hole. But eventually, inevitably, it crosses the line. Did you know that astronomers have only recently begun to detect the signals of these encounters? In 2021, the first confirmed observation of a black hole swallowing a neutron star was reported. The collision was so far away that its light never reached us, but its gravitational waves did. Tiny ripples in space-time that traveled across hundreds of millions of years, until they brushed gently against the instruments of LIGO and Virgo. And for a moment, humanity listened to the sound of a star being devoured. The image is haunting. A neutron star, once the blazing core of a massive sun, now pulled apart, piece by piece, by the relentless tides of gravity. Matter ripped from its surface, spiraling into the black hole, heating, glowing, radiating like sparks before being swallowed by a flame. And then silence. The neutron star is no more. Only the black hole remains, a little heavier, a little darker, its secrets a little deeper. And yet, even in this destruction, there is creation. The ripping apart of a neutron star may scatter heavy elements into the cosmos, seeds of gold, platinum, and uranium thrown outward before the final plunge once again. The universe reminds us that endings are also beginnings, that even in the jaws of a black hole, something can be given back. Matter reshaped, light flung outward. A legacy of a star's last resistance. Imagine lying beneath a night sky. The stars above seem calm, eternal, unmoving, and yet, hidden among them, these silent dramas unfold. Collisions we will never see with our eyes, events that shake the very structure of space-time, passing through us as faint ripples we cannot feel, but which our instruments can now detect, each detection a clue, each ripple a whisper of a story that took place millions of years ago. Stories the universe has been telling long before we learned how to listen. There is suspense in this thought that the universe is alive with events stranger than fiction. That while we go about our quiet lives, stars are being torn apart, neutron stars devoured, black holes growing heavier, and yet, somehow, these distant tragedies bring beauty into our world. The very atoms of our bodies, the iron in our blood, the calcium in our bones, were forged in stellar deaths, and some perhaps were scattered by encounters like these. We are, in the deepest sense, the children of such collision. And here is something even more mysterious. When a black hole consumes a neutron star, it may briefly create a burst of light, or it may vanish completely in silence. The difference depends on size, on speed, on angles invisible to us. This uncertainty keeps astronomers searching, because each collision is not just an ending, it is a laboratory, a place where physics stretches to its breaking point, where matter is crushed beyond what we can imagine, where space and time are twisted like fabric in a storm, and by listening to the ripples, we learn what we cannot see. So let us pause here and reflect on this strange duality, destruction and creation, silence and revelation. The neutron star, dense and bright in its own right, meeting the black hole, silent and endless. Together they create something neither could alone, a story written in gravity, a whisper carried across space, and to us, it becomes both knowledge and wonder. As you lie here, perhaps your eyes growing heavier, consider that you, too, are part of this story. Your atoms forged in fire, you're being woven from the same universe that births stars and swallows them. You are not separate from these cosmic events. You are their outcome. You are their legacy. And in this realization, perhaps there is comfort, that even when we feel small, we are never insignificant. We are part of the same dance, the same rhythm, the same endless unfolding of the cosmos. And so, as we drift forward, let us carry this suspense with us gently, knowing there are deeper mysteries still to come. For beyond neutron stars and black holes, there are questions about time itself, about the boundaries of reality, about what lies inside the event horizon. Questions we will never answer fully, but which invite us to dream. For now, settle into the night, breathe softly, and let the story of neutron stars and black holes fade into silence, as steady and calming as your own heartbeat. Have you ever wondered if time always flows the same way? We wake up in the morning, we see clocks ticking, we feel days pass, and it seems so steady, so reliable, but the universe does not agree. The universe whispers a stranger story. That time itself bends, stretches, slows, and sometimes nearly stops. And nowhere is this more dramatic than near neutron stars and black holes. Imagine yourself walking through a quiet meadow at dusk. The grass is long and golden, the wind moves gently. You hear the soft rhythm of your footsteps, each one the same distance apart. Time feels even, reliable, safe. Now imagine you reach a cliff, and on the other side, the air feels heavier. The sounds slow, as if the world itself has grown tired. That is the effect of gravity on time. The stronger the gravity, the slower the clock. Not a clock built by humans, but the clock of the universe. The beating of atoms, the pulse of light, the rhythm of reality itself. Neutron stars are some of the densest objects in existence, so dense that a spoonful of their matter weighs more than a mountain. Their gravity is immense, and under that gravity, time itself slows. If you stood safely on the surface of a neutron star, which you cannot, but let us imagine, 1 minute of your time would not match 1 minute for someone far away. Your heartbeat, your breath, your very thoughts would move more slowly, and you would never notice. To you, time feels normal. But to the outside universe, you are slowed, stretched, moved gently into the rhythm of eternity. Black holes push this idea further. so far that the human mind struggles to grasp it. Near the event horizon, time dilates enormously. A second for you could be hours, days, or years for someone watching from afar. From their perspective, you would appear to move endlessly, slowly, as though frozen on the edge, never crossing, never falling, but from your own view, you would fall quickly, inevitably, crossing the horizon in moments, slipping into silence. Two perspectives, both true, both irreconcilable. Did you know we have measured this time dilation here on Earth? Satellites orbiting our planet feel slightly less gravity. Their clocks tick just a little faster than ours. We must adjust GPS satellites daily for this difference, without correcting for relativity. Your map would place you miles away from where you truly stand, and that is on Earth. Imagine the staggering difference at a neutron star, or near a black hole. Time becomes a landscape, and gravity sculpts its shape. Now picture this, a pair of twins, one remaining safely on Earth, the other somehow traveling close to a neutron star. When the traveler returns, they are younger than their sibling. Not by choice, not by perception, but in reality, their clocks, their cells, their atoms have experienced fewer moments. This is no thought experiment only, it is a real feature of our universe. A reminder that time is not absolute, it is woven, pliable, tied to the threads of space itself. Astronomers look at neutron stars and black holes not just as mysteries, but as laboratories of time. By studying how light curves and how pulses shift, we learn how time behaves under pressures we cannot reproduce on Earth. A pulsar, a neutron star that beams light like a cosmic lighthouse, is one of the most precise clocks in the universe. Yet, even its steady rhythm slows when gravity bends it. Each pulse is a whisper, a message carried across space, a way for us to measure the flow of time on cosmic scales. There is suspense in this truth, because it means our everyday experience is not the full story. We trust our watches, our calendars, our aging bodies, but beyond Earth, time itself is a shifting, changing thing. The closer you move to the heart, the slower you drift through existence, and one cannot help but wonder, what if time could nearly stop? What if someone, somewhere, found a way to linger on the edge of a black hole? To them, a lifetime could pass in stillness, while the universe ages and dies around them. Stars born and gone, galaxies formed and faded, and they would never know. For them, it would feel only like an instant. There is a poetic strangeness here, that perhaps immortality is not a matter of avoiding death, but of stepping into slower time, living near the horizon of eternity, the body unchanged while the cosmos races ahead. And yet, such a fate would also be a curse, to see the universe die in a heartbeat. To feel yourself cut off from all you love, for every gift of science comes with shadows, and time is no exception. As you breathe gently now, feel the rhythm of your own body, your pulse, steady, quiet, constant. This is your clock, your universe of moments. And though gravity bends time, though neutron stars slow it, and black holes nearly stop it, your time is yours, unique, unrepeatable, precious. The universe has scattered endless wonders across space, but none is more personal than the seconds you hold in your own chest. And so, let us carry this thought into rest, that time is not an enemy, not a tyrant, but a companion. It bends and shifts. Yes, it stretches in ways we may never fully grasp. But it also grants us rhythm, breath, memory, love. Even in the vastness of space, where time slows and halts and collapses, there is beauty in knowing that each moment we live is our own. A small flame against the dark, a quiet pulse, a reminder that while the universe bends, we belong within it, not apart from it. So let us drift further into the mysteries yet to come, knowing that time itself is part of the story, knowing that with every heartbeat you are connected to the stars, to the neutron stars that slow their seconds, to the black holes that pause eternity. You are woven into that fabric, part of the same tapestry. And as you let your eyes grow heavy, you may feel comfort in that belonging. The universe holds you, and in its slow, infinite rhythm, it will carry you gently into sleep. Have you ever stood by the ocean at night, the waves rolling in endlessly, the stars glittering above, and then, in the distance, a beam of light sweeps across the horizon? A lighthouse turning slowly, warning ships of the shore, guiding travelers through the dark. Now imagine a lighthouse, not made of stone and fire, but of a dead star spinning with unimaginable speed, casting beams not of fire but of pure radiation. That is what we call a pulsar. Picture yourself lying beneath a quiet night sky. All looks still, silent, unchanging. But hidden among the stars are these cosmic beacons. Neutron stars spinning so quickly they flash light across the universe. Each spin sending a pulse of energy outward, like the tick of a clock too vast for human hands to build. And these pulses are so precise, so perfectly measured, that they rival the most accurate clocks on Earth. The story begins when a massive star explodes in a supernova, its outer layers scattered into the galaxy, its core collapsing inward, crushed by its own gravity. If the star is just the right size, it does not become a black hole, but instead forms a neutron star. And if that neutron star spins and beams radiation, it becomes a pulsar, a cosmic lighthouse, a ticking reminder of how violent endings can create something strangely beautiful. Did you know that the first pulsar was discovered in 1967 by Jocelyn Bell Burnell, a young graduate student who noticed a strange signal on her radio telescope? It was a repeating pulse, too steady to be noise, too regular to be an accident. At first, some even wondered if it was a signal from alien life. They called it LGM, short for little green men, but soon more were found. And the truth became clear. This was no alien signal, but the heartbeat of the universe, a neutron star announcing its presence. The suspense lies in the numbers. Some pulsars spin once every second. Others spin hundreds of times in a single second. Imagine a sphere heavier than the sun, only about 20 kilometers across, spinning faster than a blender blade. Its magnetic field so strong that it funnels energy into beams. And those beams sweep across space if Earth happens to lie in their path. We see a pulse, and so, across the galaxy, invisible lighthouses sweep endlessly, some spinning for millions of years without missing a single beat. Astronomers use pulsars as tools. Their regularity is so perfect they can test the nature of space and time itself. They can detect ripples from colliding stars. They can measure the structure of our galaxy. They can even serve as cosmic GPS signals for spacecraft. Imagine a future where astronauts navigate not by stars alone, but by pulsars, reading the flashes of dead suns as though they were signposts, guiding them through the infinite night. And yet, pulsars are not only clocks and tools. They are mysteries. Some suddenly glitch, their rhythm disrupted. As if something inside them shifts, others fade. Their beams no longer reaching us, as though the lighthouse turned away forever. There are pulsars locked in binary systems, dancing with companion stars, their light twisted by gravity into strange patterns. And some are millisecond pulsars, spinning so fast it defies belief. A dead star rotating hundreds of times every second. How does matter not tear apart under such strain? How does something so broken shine with such precision? These are questions that keep astronomers searching. Now let us reflect more gently. There is something deeply poetic in the idea of a pulsar, a star that died yet still shines, not in the steady glow of youth, but in the disciplined rhythm of a cosmic heartbeat. Its light no longer its own, but channeled, directed, sweeping outward into the universe, like a soul that refuses to vanish, finding instead a new way to speak, a new way to be seen. Perhaps there is comfort in this thought that even endings need not be silent, that transformation can create new forms of beauty. The pulsar is a story of resilience, a reminder that even in collapse, there can be rhythm, there can be light, there can be purpose. As you listen to these words now, maybe you feel your own heartbeat slowing as sleep draws near. Imagine it in harmony with those distant pulses, your chest rising and falling like a lighthouse beam, guiding you gently across the sea of night. You are not separate from these stars. You are part of the same story, built from the same matter, shaped by the same laws. And in your quiet pulse lies the same truth, that life continues, that rhythm endures, that light, once born, does not easily fade. And as we move forward, there will be deeper mysteries still. 4 pulsars are only one chapter in the book of neutron stars. There are stranger things ahead. Stars colliding, magnetars bursting with fury, and black holes twisting space itself. But for now, let the image of the lighthouse remain, a steady beam sweeping across the cosmic sea. A reminder that even in the darkest night, something shines, something calls, something guides us home. Have you ever wondered what the strongest force in the universe might be? You might think of gravity, holding planets and stars in their orbits, or perhaps the explosive power of a supernova. But there is something stranger, something rarer, a force that hides within the heart of a few unusual neutron stars. And that force is magnetism, not the simple pull that sticks a note to your refrigerator, but a magnetic field so immense it could erase every credit card on Earth from halfway across the galaxy. A magnetic field that could twist atoms into unfamiliar shapes. A magnetic field born of collapse and fury. These stars are called Picture yourself standing at the edge of a vast desert. The air is still, the sky is endless, and suddenly, a storm appears on the horizon, not of sand, but of lightning, bolts too large to comprehend, the sky cracking open with blinding fire. That is what a magnetar feels like, a storm contained in a star, a storm whose power exceeds anything our minds can easily hold. Magnetars are neutron stars, but they are rare. Perhaps 1 in every 10 neutron stars becomes a their defining feature is their magnetic field, up to 1,000 times stronger than that of ordinary neutron stars. Imagine the Earth. Now imagine a magnet billions of times stronger than anything humans can create. So strong that if a magnetar were as close as the moon, it could strip the electrons from the atoms in your body. It would not need to touch you. Its presence alone would unravel matter. Did you know that magnetars are responsible for some of the brightest flashes of energy ever seen? In 2004, a magnetar thousands of light years away released a burst so intense it briefly altered Earth's upper atmosphere for a fraction of a second. It was brighter than all the stars in the sky combined, and yet this storm came from a star only 20 kilometers wide, a star the size of a city, but holding the rage of a galaxy. Astronomers call these bursts starquakes. The crust of the magnetar cracks under the strain of its own magnetic field, like the Earth's crust during an earthquake, but far more violent when it breaks. Energy is unleashed in a storm of gamma rays, invisible but devastating. A reminder that even dead stars are not silent, that they can roar with the fury of creation itself. And yet, magnetars do not burn forever. Their energy fades with time, their magnetic storms calm. They may live only a few thousand years before quieting into more ordinary neutron stars. In the lifespan of the cosmos, they are brief and violent flashes. But while they live, they are unmatched in their power. Silent predators of energy, beacons of intensity, their storms crossing light years. Now let us reflect more softly. There is something haunting in the idea of stars that could tear apart atoms, stars that could shake the fabric of space, and yet they exist quietly, hidden among millions of calmer suns. Most will never be seen, most will never flare, but somewhere, perhaps right now, a magnetar is trembling, its crust straining, its field twisting, preparing to erupt, a cosmic heartbeat we cannot hear. Until suddenly, it shouts across the void. And what does this tell us about ourselves? Perhaps that power does not always announce itself, that the strongest forces may lie unseen, that violence and beauty can emerge from the same collapse. The magnetar is not gentle, it is not steady, but it is real, and its reality is part of the story of the universe, a reminder that extremes exist and that they, too, belong to the great unfolding. As you breathe now, slowly, gently, consider how fragile we seem in comparison, our bodies small, our world delicate, and yet here we are, able to tell the story of stars, able to imagine their storms, able to translate their fury into wonder. The magnetar cannot know itself, but you can know it. You can weave its existence into your own dream. And perhaps there is power in that, a different kind of power, the power of awareness, the power of connection. So, as we drift forward into the next mysteries, let us carry the magnetar with us, not as a threat, but as a symbol of intensity, of how the universe holds within it, and yet still makes space for silence, for sleep, for the quiet ticking of your own heartbeat, for every starquake in the heavens. There is a soft breath on earth, for every burst of gamma rays. There is a whisper of comfort, the storm and the stillness, the chaos and the calm. And now, as your eyes grow heavier, imagine the magnetar fading into the distance, its storms less threatening, its power softened by time, leaving only the memory of its light, the calm after the storm, the quiet that follows thunder. And in that quiet, and so too may you, have you ever wondered where gold comes from? Not the gold in jewelry shops or the coins in old stories, but the gold buried deep in mountains, the gold woven into wedding rings, the gold that humans have chased across centuries. We prize it, we measure wealth with it, we celebrate love and power through it, but its true origin is far stranger than any myth. For gold is not born in the quiet heart of an ordinary star. It is born in collisions, in the meeting of neutron stars, where gravity and violence transform matter into treasure. Picture yourself in a vast, silent sky, two faint lights moving in slow circles, unnoticed by most of the universe. These are neutron stars, remnants of giants long dead, each one small as a city, yet heavy as the sun, and they circle closer and closer. Every orbit a little tighter, every second a little faster, until their dance becomes a spiral of doom. For millions of years they may circle, but eventually gravity pulls them together. And when they finally meet, the universe shakes. Neutron star collisions are among the most violent events ever witnessed. When they crash, the impact sends ripples through space-time itself, gravitational waves racing across the cosmos. We detected such an event in 2017, an event so far away it happened before humans existed, and yet its ripples reached us, shaking our instruments with the faintest whisper, a whisper that told a story of fire, light, and creation. Did you know that when two neutron stars collide, they create heavy elements, not just gold, but platinum, uranium, and more? These elements are too heavy to form in ordinary stars. They require energy and pressure so extreme that only collisions of collapsed stars can forge them. In that single 2017 event, astronomers believe an amount of gold was created greater than the mass of the Earth. One cosmic collision producing treasure enough to outshine every mine humanity has ever dug. Imagine the scene: two stars collide, their crusts tearing apart, matter thrown outward in glowing waves, jets of light shooting into space, the crash bright enough to outshine entire galaxies for days. From the wreckage, a black hole may form, or perhaps a heavier neutron star, but around them, clouds of molten gold and platinum expand, floating through the galaxy, seeds of future planets, atoms that may one day form into rings, crowns, or the circuitry inside a computer. Even into the cells of your own body, there is suspense in this idea that the metal on your finger or the gold leaf on ancient art was born in a collision of dead stars, that when you touch it, you touch the memory of cosmic violence, matter torn apart, reformed, and scattered over billions of years, and carried across space until it became part of Earth, part of us. It is as if the universe itself wove beauty into chaos, leaving behind reminders that destruction can give rise to wonder. Astronomers call the light from these collisions brighter than a nova, dimmer than a supernova, but uniquely colored. Their light carries the fingerprints of heavy metals, a cosmic signature written in fire. When telescopes catch these flashes, they are not just watching an explosion, they are watching alchemy, the universe turning base matter into something rare and enduring. And yet, for all their beauty, Neutron-star collisions are rare. Galaxies may wait millions of years to see just one. The rarity of gold on Earth reflects the rarity of such events. It is not common, it is not easy, it is a jewel forged in catastrophe. A reminder that some things are precious because they are born in moments that will never be repeated. Now pause for a moment and reflect on the intimacy of this. Every human culture has valued gold, woven it into myth, chased it, fought over it, and yet none of them knew until recently that its origin lay not in the earth, but in the stars. We have always treasured it. But now we know why, because it is rare, beyond comprehension, because it is born only in the final embrace of stars that gave everything in their death. As you breathe gently now, consider what this means for you, that the atoms you carry, the jewelry you wear, the treasures you pass on, all were born in collisions older than history, older than Earth itself. You are connected to those events. You carry their legacy in your own hands, and when you rest as part of the same cosmos that collides, creates, and remembers. There is comfort in this, that even in chaos there is creation, that even in endings there are beginnings, and that from destruction the universe builds new wonders. Gold for rings, platinum for art, and elements for life itself. It is a reminder that beauty and meaning are not apart from violence, but often born through it. So let us drift now, leaving behind the vision of colliding stars, the sparks of gold scattering through galaxies, the ripples of gravity spreading endlessly outward. We carry with us the knowledge that every treasure has a cosmic story, and that by listening, we too become part of it. The stars may collide in silence far away, but their whispers reach us and guide us gently toward dreams, where creation and comfort are one and the same. Have you ever wondered what it means for something to vanish? Not to break apart, not to scatter, but to truly disappear, to fall into a place where the rules of our universe seem to stop, where space itself curves inward and time slips away. This is the riddle of black holes, and tonight, as you close your eyes and let your thoughts soften, we will drift toward the edges of these cosmic mysteries, exploring how black holes are born, and what it means when a star's life collapses into darkness. Imagine a star at the end of its life. For millions of years, it has burned brightly. Its light has traveled across the void. Its warmth has shaped the skies of nearby worlds. But stars cannot shine forever. Eventually, the fuel runs out. The fire in the heart fades, and gravity, that patient and relentless force, begins to take control. The star collapses inward, layer after layer, falling toward the core, until the pressure is greater than anything we can imagine. This collapse is sudden, violent, unstoppable, and from it, a black hole is born. Picture this moment. The star shrinks rapidly, its core crushed, smaller and smaller. Atoms squeezed beyond recognition, matter forced into a singularity, a point so dense that space itself curves into it. We call the boundary around it the event horizon, a name that sounds like poetry, and in truth, it is. It is the line where nothing escapes, not even light. Cross it, and you vanish from the universe's view. Cross it, and you enter a realm where time and space themselves collapse. But here is the suspenseful part. Black holes are not only born from collapsing stars. They can also emerge from the union of neutron stars, two collapsed giants spiraling together. Their final embrace, so violent it tears them apart. And from the wreckage, a black hole may form in that moment. The last remnants of light blaze outward, while the center disappears into a silence so deep it swallows everything around it. Creation and destruction unfolding together. Scientists describe black holes with mathematics, with Einstein's equations of relativity. But to imagine them, we must go beyond numbers. Think of a whirlpool in the fabric of space, a spiral pulling everything inward, not water, but time itself slipping down. The closer you come, the slower time runs. A minute near the event horizon might be hours, days, even years, for someone far away. In this way, black holes do not only consume, they bend reality, they stretch the rhythm of time. They remind us that the universe is stranger than any dream. Did you know that black holes can sing, not with sound as we know it, but with vibrations in space-time? When black holes collide, they create ripples, gravitational waves, waves that hum across the cosmos. We have detected these whispers, signals of invisible giants meeting in the dark. It is as if the universe itself plays a deep, resonant music, a song of endings and beginnings. Now consider this. Inside a black hole lies the singularity, a point where our laws of physics break, where gravity becomes infinite, where space and time are twisted together. We cannot see it, we cannot measure it directly. It hides behind the horizon, a secret locked away. And yet its existence tells us that there are truths we do not yet understand, questions that lie beyond the reach of even our brightest minds. And perhaps that mystery is part of the comfort, that the universe is not finished, that there is more to learn, more to wonder about, more to dream of, for all their darkness. Black holes are not only destroyers, they shape galaxies. They sit at the centers of nearly every galaxy we know, including our own Milky Way. A giant black hole rests there. Calm now, but once devouring stars and gas, its hunger shaping the spiral arms of our home. Without black holes, galaxies might never have formed as they did without them. Perhaps life itself would never have emerged. Even in their silence, they give structure to the universe. Pause for a moment and think about the paradox. Something that destroys also creates. Something that swallows light also paints the shape of the heavens. This is the lesson black holes whisper to us, that endings and beginnings are often the same thing, that collapse can give birth to beauty, that silence can carry meaning. Now as you breathe slowly, picture yourself drifting near a black hole, not too close, just near enough to feel the curve of space. Stars bending around you, time flowing gently slower. The universe stretching outward like a dream. It is not frightening, it is serene. A reminder that even the most powerful forces have a quiet side, a side that invites us to rest, to release our racing thoughts, and simply float. In the end, black holes remind us of mystery, of the boundaries of our knowing. They remind us that the cosmos is vast, and that we are small, but also that we are part of it, made of the same stardust, shaped by the same gravity, listening to the same silence. So, as you let your eyes grow heavy and your breath slow, remember that the universe is holding you as surely as gravity holds the stars. You do not need to solve every mystery. You only need to rest. For the cosmos itself is still unfolding, and you are part of its story. And with that thought, we drift gently forward, leaving the mystery of black holes for now, knowing there is more to explore, knowing there is always more to wonder. But for this moment, there is only calm, only quiet, only rest. Have you ever wondered what it would feel like to stand at the edge of forever? Not metaphorically, not in a dream, but truly at a place where the universe itself says, "This far and no further, this place exists." It is called the event horizon, the invisible boundary that surrounds a black hole. A horizon not of land or sea, but of time and light. It is a threshold unlike any other, a place where physics bends, where light cannot escape, where even stories end. Picture yourself drifting in the calm of space. The stars glitter faintly, your body is weightless, and before you is a sphere of darkness, perfectly round, perfectly still. You do not see the black hole itself, but you see the boundary, the region where light bends so strongly that it circles endlessly, creating a glowing ring around the void. This is the event horizon, a surface without surface, a gate without a door, the edge of all things. Scientists describe it in simple terms. The event horizon is the point of no return. If you cross it, you are gone from the visible universe. You could scream, you could shine a flashlight, but no signal would ever leave. Even light is trapped. It is the ultimate silence. And yet, from far away, it is beautiful. Because light near the edge bends into arcs, galaxies behind it distort into halos. The sky becomes a strange and shifting mirror, as if the black hole wears a crown of fire. Here lies the suspense. What would happen if you approached it? If you let yourself drift closer, time itself begins to change. To an observer far away, your movements slow. Your fall toward the horizon looks endless. It takes forever. They would never see you cross. To them, you freeze on the edge, fading into red light, stretched thinner and thinner, until you vanish. But to you, the traveler, time feels normal. You continue forward and cross without hesitation. What does that mean? Two truths existing at once. This is not fantasy. This is the reality of time dilation. The warping of time near a black hole. Imagine holding a clock in your hand. You watch its hands tick steadily, but a friend far away sees it move slower and slower until it seems to nearly stop. This is what gravity does to time. The stronger the gravity, the slower the time. And at the event horizon, time stops entirely, not for you, but for the outside world. It is as if the universe places a bookmark there, a frozen moment, while you continue on. This idea may feel unsettling, but there is wonder in it too, because it shows us that time is not fixed. It bends, it stretches, it flows differently depending on where you are. Every black hole is not just a place, but a machine for time itself. A reminder that the universe is not as rigid as it seems, that the ticking of a clock, the beating of a heart, are part of a much larger rhythm, one that changes in the depths of gravity. Did you know that if you orbited near a black hole, you could see the entire future of the universe unfold? Because time for you would be slower, while the cosmos outside would rush ahead. A few hours for you might be millions of years elsewhere. Imagine looking up and watching galaxies drift apart. Stars born and die, civilizations rise and vanish, all in the span of a single breath. The event horizon is not just a place of endings. It is a window into the flow of eternity. Now, think about the beauty of this. The event horizon is silent. It makes no sound. It offers no warning. And yet, it is one of the most dramatic places in existence. A line that separates what can be known from what cannot. The outside world will never see what lies beyond. It is forever hidden, and perhaps that secrecy is part of its power. For in every mystery lies meaning, and in every unknown lies wonder. Some scientists dream that beyond the horizon there might be other realities, other universes, that black holes could be gateways, cosmic tunnels that connect distant places. We do not know if this is true. We may never know. But the thought itself is enough to send the imagination soaring. To think that what seems like an ending could secretly be a bridge, a passage into another chapter of creation. Now, as you breathe deeply, picture yourself hovering just outside the horizon, safe but close enough to see the warping of light. The sky ripples like water. The stars bend into circles. Your heartbeat slows. The universe feels quiet. Here at the edge of forever, there is no need to rush. Time itself has stretched for you. You are cradled in the gentlest pause, held in the gravity of wonder, and soothed by the silence of infinity. The event horizon is not only a scientific boundary, it is also a metaphor for all the edges in life we cannot cross, for the mysteries we must accept, for the things that lie beyond our knowing. It teaches us that it is okay not to see everything, that sometimes it is enough to stand at the threshold, to admire the light bending around the unknown, to rest in awe rather than certainty, and to allow the unanswered questions to become part of our peace. So let us drift onward now, leaving the horizon behind us, not with fear, but with a quiet respect. For it reminds us of the vastness of the cosmos, the strangeness of time, and the beauty of boundaries. As you rest tonight, remember that not all mysteries need to be solved. Some can simply be admired, like the glow of starlight at the edge of darkness, gentle, eternal, waiting for us to dream. Have you ever wondered what would happen if you fell into a black hole? It sounds like the beginning of a frightening question, but here, in the quiet of the night, we will explore it gently, not as something to fear, but as one of the most fascinating and surreal journeys the cosmos can offer. Because what happens at the edge of a black hole is unlike anything else in nature. It is a place where matter itself is stretched, where falling becomes a transformation, and where the ordinary rules of the universe unravel. Astronomers have given this strange fate a playful name, spaghettification. It sounds light-hearted, almost humorous, but what it describes is deeply strange. Imagine your body, or any object at all, pulled and stretched into a thin, elongated thread, as if the universe itself were rolling you out like soft dough beneath infinite hands. This stretching is caused by tidal forces, the same kind of forces that make waves rise and fall in the ocean. But here, magnified beyond imagination, picture yourself drifting closer to a black hole. At first, everything seems quiet. The stars still shine behind you. The pull feels gentle, but as you move closer, the difference in gravity from your head to your feet begins to grow stronger. If your feet are nearer the black hole than your head, they are pulled harder, stretched downward with greater force, while your head is pulled more weakly. The result is a stretching effect. At first subtle, but then dramatic, as though your very form is being drawn into a cosmic thread. Scientists explain this with simple words. Gravity near a black hole changes so quickly with distance that the closer part of your body feels a much stronger pull than the farther part. This difference tears things apart, molecules first, then atoms, and then the very structure of matter itself. It is not a ripping so much as a stretching, a drawing out into impossibly long, impossibly thin strands. And so the term spaghettification was born. But do not think of it only as destruction. There is also wonder here, because in this process we glimpse the raw power of gravity, the same force that holds planets in orbit, that shapes galaxies, that keeps our feet on the Earth, also has the capacity to transform matter into something completely different. It is the ultimate reminder that gravity is not just gentle and steady. It can be wild, fierce, a sculptor of extremes. Now imagine the perspective of an outside observer, someone watching you fall toward the black hole. They would never see you cross the horizon. Your form would stretch, slow, fade into red light until it seemed to freeze. An endless falling that never completes. To them, you become an eternal shadow on the edge, a ghost written into the fabric of space-time. But from your perspective, you continue downward, unaware of the freeze, carried smoothly forward until the stretching begins. This paradox creates suspense. Two stories unfolding at once, two truths existing together. From one point of view, you vanish. From another, you continue. And somewhere between the two lies the mystery of what it means to cross into the unknown. Did you know that spaghettification depends on the size of the black hole? If the black hole is small, the stretching begins outside the event horizon, dramatic and violent. But if the black hole is massive, the tidal forces at the horizon are gentler. You could cross the boundary without noticing. The stretching delayed, only becoming intense, deeper inside. This means that not all falls are the same. In some cases, you would be spaghettified quickly. In others, the experience would be more gradual, a slower unraveling into infinity. And here lies something almost poetic, that even in destruction there are variations of grace, different tempos of dissolution, different rhythms of farewell. The cosmos composes endings in many different ways. Now pause for a moment and reflect on what this teaches us. Spaghettification is not simply about matter being torn apart. It is a symbol of scale, of how different the universe can be at extremes far from our daily life. On Earth, gravity is mild, gentle. We feel it in the tug of the ocean's tides, in the steady fall of an apple. But near a black hole, that same force writes stories that seem stranger than any dream. It is the same law, the same equation, but expressed in a far louder voice. Think of the beauty in that. The ordinary and the extraordinary are two expressions of the same truth. The pull that guides a falling leaf is the same pull that stretches stars into ribbons, that draws matter into threads of light, that sculpts the boundaries of galaxies, and creates the mysterious silence of black holes. We live in a universe unified by simple forces, but expressed in infinite ways. As you breathe gently now, picture yourself not as a victim of spaghetti, but as a traveler transformed, your form elongated into light, your atoms stretched into streams, blended into the very fabric of the black hole. You are no longer separate, no longer bound by shape. You have become part of the story of gravity, part of the mystery written at the edge of forever. There is a strange comfort in this, the idea that even endings are not truly endings, but transformations, movements into new forms. And so, as you drift closer to sleep, let the thought of spaghettification not trouble you, but soothe you. It is a reminder of scale, of mystery, of the creativity of the cosmos, that even destruction can be woven into poetry, that even silence can sing, that even in being stretched thin, you are still part of the great whole. So let us leave the horizon now, drifting outward again, carrying with us the knowledge that black holes do not just swallow, they transform, that the universe does not simply end things, it reshapes them, and that we, too, are always being reshaped by time, by gravity, by dreams. As you close your eyes, rest in the thought that you are held gently, not torn, not stretched, but comforted by the rhythm of the universe, a rhythm that hums quietly, even at the edges of infinity. Have you ever wondered what happens after the fall? Not the fall of a leaf from a tree, not the fall of a body into water, but the fall across the event horizon, into the darkness of a black hole. We have spoken of horizons, of time slowing, of spaghetti. But what lies beyond that veil? What lies at the very center? This question has haunted scientists, dreamers, philosophers, because the truth is both breathtaking and unsettling. At the heart of a black hole lies the singularity. Imagine a place where matter is compressed into an infinitely small point, not just stars, not just planets, but everything reduced into density so vast that our equations break down. It is a place where gravity becomes infinite, where space-time curves so tightly that it folds in on itself. At the singularity, our knowledge stops. Our understanding shatters, for here, the laws of physics as we know them no longer apply. This is suspense in its purest form, because the singularity is not simply unknown, it is unknowable, a place hidden forever beyond the horizon, shielded from our eyes, even from our instruments. We cannot look inside, we cannot measure. We can only imagine, and so the singularity has become a canvas, where science paints theories and imagination fills in the rest. Picture yourself falling inward. You cross the event horizon. You feel the stretching of spaghettification, but you continue deeper and deeper. Time itself unravels around you. Space becomes strange. Directions lose meaning. Up and down, in and out, no longer apply until at last you reach the singularity, a place without place, a point without size, an end and a beginning in one. Did you know that some scientists believe the singularity may not truly exist? It may only appear in our math, because our equations are incomplete. We do not yet have a theory of everything, a way to unite gravity and quantum mechanics. Until we do, the singularity remains both real and unreal, a signpost pointing toward deeper truths. It is as if the universe whispers, "There is more to learn, there is more you cannot yet see, but there are other possibilities too." Some imagine that black holes may not end in singularities, but in bridges, gateways through space-time. Einstein himself once wrote of wormholes, tunnels that might connect distant parts of the cosmos. Perhaps inside a black hole lies a passage, not to an end, but to another place, another universe, another beginning. We do not know if this is true, but the thought itself carries a thrilling suspense, that what seems like a tomb might secretly be a doorway. Now consider this. Every black hole has an interior that is forever hidden from the outside. No signal can escape, no light can reveal it. The black hole shapes the galaxy around it. It bends the paths of stars. It powers jets of energy that blaze for millions of light years. It leaves fingerprints across the cosmos, even though its heart is sealed in this way. The singularity is like a secret, one that changes everything without ever being seen. Pause for a moment and reflect on the poetic truth of that. We, too, carry singularities within us, hidden places no one can see. The core of memory, the mysteries of thought, the depths of emotion. Our singularities shape who we are, even though they remain unseen. And just as with black holes, it is okay not to fully understand them. It is enough to know they exist, to accept their power, to rest in their mystery. The suspense of the singularity comes from what it suggests about the future. If matter collapses into infinity, does it remain trapped there forever? Or could it one day emerge, transformed, released into another form? Could black holes be seeds of new universes, each singularity exploding outward into a fresh Big Bang? Perhaps our own universe began this way. Perhaps the birth of everything we know was the death of something else. Now imagine this vision as you breathe. You are floating not in fear, but in wonder, looking inward toward the singularity. You do not need to solve its riddle. You only need to admire it. A place where science and mystery meet. A reminder that some truths are not meant to be held tightly, but to be dreamed about. The singularity is not a monster, it is a question. And sometimes questions are the gentlest companions of all. And so, as you drift toward rest, let this idea comfort you, that even the darkest places in the universe hold secrets that may one day bloom into light. That what seems like an end may be the beginning of something new. That hidden in silence are the seeds of creation. Black holes do not only swallow, they also invite us to wonder. They remind us that the unknown is not empty. It is full of possibility, full of dreams. So let us leave the singularity now, floating outward once again, carrying with us the awe of what we cannot see, the peace of what we cannot solve, and the comfort of mystery. For the night itself is a horizon, and dreams are our singularities, places where time bends, where logic dissolves, and where new worlds are born. Have you ever wondered if a black hole is not just an ending, but also a doorway? A hidden passage written into the very architecture of space-time. When we gaze into the blackness of a collapsed star, are we looking at a tomb, or are we looking at a tunnel? This is the suspense that has stirred scientists and dreamers alike. Because buried in Einstein's equations is the tantalizing suggestion that wormholes may exist. Picture yourself in the stillness of the night, lying beneath a velvet sky scattered with starlight. Now imagine the stars are not fixed, but connected by invisible threads, passages curving between them, like hidden hallways in a vast mansion of the cosmos. What if, instead of traveling for thousands of years across interstellar distances, You could slip into one of these hallways, step through a hidden door, and emerge instantly on the other side of the universe. That is the promise of a wormhole. Scientifically, a wormhole is a bridge, a tunnel that connects to distant points in spacetime. Einstein and his colleague Nathan Rosen first described the idea. So wormholes are sometimes called Einstein-Rosen bridges. The math allows for such tunnels, curving through the fabric of reality, like shortcuts through the infinite. But the challenge is, they may not last, they may collapse too quickly. They may be too unstable for anything to travel through. And yet the idea lingers, like a haunting melody at the edge of sleep. Now imagine walking through one. You step beyond the horizon of a black hole, but instead of a crushing singularity, you find a corridor of curved space. Glowing softly with strange light, the tunnel bends, it twists. It feels both infinite and immediate. And when you emerge, you are somewhere entirely new. Perhaps another galaxy, perhaps another universe altogether. The suspense lies in not knowing, for this is no ordinary journey. This is the crossing of existence itself. Did you know that some scientists believe wormholes might already lace our universe? Tiny quantum wormholes that flicker in and out of existence, appearing for an instant, then vanishing before they can be used. This concept is called quantum foam, a restless churning at the smallest scales of reality, where space itself is alive with possibilities. If wormholes exist here, could larger ones exist too? Could black holes be the anchors, the openings that hold these tunnels wide? If so, then black holes are not only destroyers, but also cosmic doorways, silent thresholds waiting to be crossed. But here the suspense deepens, because wormholes, if real, would raise profound questions. Could they allow time travel if you link to points in space? Do you also link to points in time? Could you walk not only across the galaxy, but across centuries? Could wormholes be the hidden rivers that carry not just matter, but memory? Some theories say yes, but always with caution, because the fabric of time is delicate, and even in theory, a traveler might risk unraveling the flow itself. Now let us pause in the tunnel. Feel the silence, feel the pull of curiosity. Suspense is not only about fear, it is about the beauty of not knowing. Wormholes embody this perfectly. They remind us that the universe may hold hidden doors, that reality may be larger than what we see, that what seems empty may be full of secret connections. From a poetic perspective, wormholes are symbols. They are metaphors for the hidden paths in our own lives. Sometimes we search for shortcuts. Sometimes we stumble into them. A sudden insight, a chance encounter, a dream that feels more real than waking. These, too, are wormholes, tunnels connecting distant points in our journey, bridging what seemed impossible, revealing that life itself is threaded with hidden passages. But in the scientific realm, the great question is stability. Could a wormhole remain open long enough to be crossed? Some say it would collapse instantly. Others say it could be held open, but only with a strange substance, something called exotic matter. This is not ordinary matter, not the kind that makes up stars and planets. Exotic matter has negative energy. It bends space-time in the opposite direction, and in theory, it could keep a wormhole mouth from closing. If such matter exists, it may be the key to holding the door open, long enough for a traveler to step through. Now breathe in deeply and picture this. A civilization advanced enough to capture exotic matter, to weave wormholes deliberately, to build highways of space-time, an interstellar web, a lattice of tunnels that span galaxies for them. Crossing the stars would be as effortless as walking from one room to another. What would they see? What would they know? And could they be watching us, even now? Through a doorway we cannot perceive, suspense lingers here, because wormholes are both possible and impossible, permitted by equations, but resisted by reality. They hover on the edge of truth, inviting us to wonder, inviting us to dream. They are not just tunnels in space, they are tunnels in imagination, inviting us to step forward, even if only in thought. And as you drift into the quiet of the night, consider this: every mystery you face, every unknown you encounter, might be a wormhole of its own, a hidden doorway, a passage to growth, to change, to new understanding. The cosmos shows us what is possible, and in doing so, it reflects what is possible in us. For perhaps the greatest wormholes are not in space, but in the heart, in the mind, in the journey we take through dreams. So let us leave this tunnel now, not with fear, but with wonder, knowing that wormholes remain suspended between science and myth, between theory and hope. They are thresholds of suspense, whispers of possibility, and reminders that the universe may always have more doors than we can see. Have you ever wondered if this universe is the only one? When you look up at the stars and feel the immensity of space stretching outward, it feels infinite. But what if infinity does not stop at our horizon? What if there are other infinities, other skies, other worlds that lie just beyond our reach? This question, quietly thrilling, leads us into the realm of parallel universes. And black holes may be the hidden doors. Imagine lying beneath the night sky. The air is still, the stars glow faintly. You feel the weight of time pressing gently upon you. Now picture that each star, each black hole, could be more than it seems. What if every black hole is a seed, a doorway to a new universe, a place where everything begins again? Scientists call this the black hole cosmology hypothesis. The idea that black holes may give birth to baby universes, hidden away beyond the veil. In this vision, a star collapses into a black hole, its core crushed to unimaginable density. But instead of ending in a singularity, it explodes outward into another dimension. The black hole we see from the outside is only the opening, the shadow, the horizon. But on the other side, a whole universe might blossom, expanding into its own space-time, its own laws of physics, its own galaxies and stars. In this way, our own Big Bang might have been the other side of a black hole, born from a parent universe we cannot see. The suspense here is breathtaking, because if this is true, then universes may be endless, one giving birth to another, like branches of an infinite tree. Each black hole a seed, each seed a cosmos, and somewhere out there, perhaps our universe itself is just a single leaf on an unimaginable forest of creation. Did you know that some theories suggest each universe could have its own unique laws? In one, gravity might be stronger. In another, atoms may never form. In yet another, stars could burn for only moments. And perhaps in some universes, life never emerges at all. while in others, it flourishes in strange and beautiful forms. The multiverse is not only vast, it is diverse beyond comprehension, and black holes may be the portals, the hidden wombs of these infinite realities. Now, close your eyes and imagine stepping through. You approach a black hole, its horizon shimmering like liquid night. You pass the threshold, you fall inward. But instead of destruction, there is birth. Light floods outward. Space unfolds around you. You find yourself not in oblivion, but in a universe newborn, its galaxies swirling like fresh paint on a cosmic canvas. Its stars igniting for the very first time. You are a witness to creation, standing at the edge of a world that no one else has ever seen. From a poetic view, this is more than speculation. It is a mirror for our own lives, because each ending we fear may be the beginning of something else. Every door closed is the start of a new path. Every collapse may be a hidden birth. Black holes remind us that even in the darkest shadows, there can be new universes waiting. We carry this truth within us, that even our endings hold the seeds of beginnings. But let us not forget the science. The equations of general relativity do not forbid such possibilities. They hint at them, they leave space for them, yet we cannot prove them because nothing escapes the black hole. No signal returns, so we are left with wonder, suspense without resolution. The door remains closed, but its presence invites us to dream. Some physicists suggest that universes could even evolve, that those producing the most black holes would give rise to more baby universes. In this view, our cosmos may be fine-tuned because it is part of a grand cycle. Universes that favor black holes survive and multiply, while those that do not fade into silence. It is cosmic natural selection, a vast evolutionary tree of universes, each branching through black holes, each expanding into its own infinite sky. Now reflect for a moment, as you breathe slowly, that you may be part of a chain so vast it stretches beyond imagination. Every star you see, every galaxy shining faintly in the dark, may be more than it appears. Each collapse a gateway, each horizon a threshold, each black hole a silent promise that creation is never truly finished. The suspense of this thought is not frightening, it is comforting, because it suggests that the universe is never wasted, that what falls also gives rise, that nothing is truly lost, and that endings are simply beginnings in disguise. As you sink deeper into rest, picture the infinite branching of universes, a tree of light growing without end. Its roots hidden in darkness, its branches filled with worlds. Each black hole a seed, each seed a creation, and somewhere among them, perhaps another version of you, drifting beneath another sky, dreaming of the same questions, wondering about the same mysteries, feeling the same awe, and perhaps the same comfort. So let us leave this thought gently, with the knowledge that the cosmos may be more than one, that beyond the black holes we fear, there may be universes we cannot count, and that the night sky above us may be only one leaf on an endless tree. As you drift toward sleep, carry this vision with you, not as fear, but as wonder, that the universe is not small, it is infinite upon infinite, dream upon dream, world upon world, waiting to be imagined. Have you ever wondered what it truly means for time to end? Not just a clock running down, not just the turning of pages on a calendar, but the flow of time itself. The current that carries every star, every planet, every life. Black holes invite us into this mystery, for they do not only trap light, they also capture time. Imagine yourself floating near the edge of a black hole. The event horizon glows faintly with its invisible presence. You try to move forward, but you feel something strange. Time itself resists you. Seconds stretch longer. Minutes refuse to pass. If someone far away watches you, they will see you slowing, moving slower and slower, until you appear frozen at the edge, never quite crossing, never quite gone. To them, you become eternal, suspended in twilight. But to you, the fall continues, and time, from your view, feels almost normal. This is the paradox of relativity, the bending of time under gravity's hand. Black holes do not just warp space, they warp time itself. The closer you are, the slower your clock ticks. The farther away, the faster time flows. This is not imagination. This is physics. Proven and tested on Earth, the effect is faint. Satellites above us feel time run just a little faster. GPS systems must account for it. But near a black hole, the difference grows extreme. So extreme that a single hour near its surface might equal years far away. Now pause for a moment and picture this: a civilization orbiting a massive black hole. On their world, a single day might stretch while outside. Centuries pass, they would live in slow motion, the universe around them racing forward, stars aging, galaxies shifting. While they remain in a bubble of suspended time, would they watch the cosmos evolve before their eyes? Would they see the birth and death of worlds as they lived a single lifetime? This is not only suspenseful, it is haunting, because it forces us to ask what time truly is. Did you know that for a black hole itself, the story of time becomes even stranger? From the outside, it appears eternal, trapping light, trapping matter. But from the inside, its timeline may be short, everything rushing inevitably toward the singularity. Time for the infalling traveler ends at the core, a final moment, a destination where every second converges. Now imagine this as a metaphor. Think of the moments in your own life when time seemed to stretch, when a single second carried the weight of years, or moments when time raced forward, slipping past your grasp. Black holes magnify this truth, showing us that time is not fixed, it is elastic. It flows differently depending on where you stand and how deeply you are pulled. But there is another suspenseful truth. Black holes may not last forever, though they seem eternal. Stephen Hawking showed us that they slowly evaporate through a process called Hawking radiation. Particles slip away from the edge, energy leaks out over billions of years. The black hole shrinks until at last it disappears. When it does, where does the information it held go? Where do the memories of what it swallowed remain? This puzzle is called the information paradox, and it has no final answer. Some say the information is destroyed. Others say it lingers in the radiation. Still others suggest it is encoded in the horizon itself. But the suspense remains. The universe has hidden the truth from us, perhaps forever. And so we stand at the edge of time, looking into the black hole, wondering if the future can be rewritten. If a path through it could lead us to another age, could black holes be not only ends, but bridges across time. If a wormhole were stable, could one side rest in the present, while the other opens in the past or future? If so, then stepping into the mouth of such a hole would mean stepping across time itself. And the suspense is unbearable, because though the equations whisper yes, reality may whisper no. Still, let us allow ourselves the dream. Picture walking into a black hole and emerging not in another place, but another era, perhaps in the deep past, where the first stars ignite, or in the far future, where galaxies fade. Could black holes be not just horizons, but gateways to time? And if so, would we dare to step through? Pause here, take a breath, and feel the comfort in this thought. Even if we cannot change time, even if we cannot travel through it, we can still reflect on it. We can still savor the moments as they pass, like travelers orbiting the edge of a black hole. We are all drifting along the curve of time, each second precious, each moment unique, even as it slips into memory from a poetic view. Black holes remind us of our place in time, that while the universe bends and twists, we are part of its unfolding. And though we may not rewrite the future, we can write the present, moment by moment, breath by breath. Each heartbeat a choice, each dream a creation. This is our time, and it belongs to us. As you rest now, let yourself imagine the edge of time, a horizon that stretches before you, dark but not empty, mysterious but not frightening. It holds questions we may never answer, but in those questions is peace. Because not all mysteries need solving. Some can simply be felt as comfort, as wonder, as the quiet assurance that the universe is vaster than we can ever know. So drift gently, carrying with you the thought that time is not fixed. It bends, it stretches, it rewrites itself in places beyond imagination. And as you breathe slowly, know that you, too, are part of this grand flow, a thread woven into the fabric of eternity, suspended in the mystery of time.